A car engine is like the heart of a car. It's the central component that brings the entire vehicle to life. Just as the heart pumps blood to keep a body functioning, the engine generates the power needed to move the car. Without it, the car would be nothing more than a stationary piece of metal and plastic. The engine is a marvel of engineering, a testament to human ingenuity and the quest for mobility. It's the part that makes the car go. When you press the accelerator, the engine responds by increasing its power output, propelling the car forward. This process involves a series of intricate mechanisms working in perfect harmony. Pistons move up and down, fuel ignites, and energy is transferred to the wheels. It's a symphony of motion and power, all orchestrated by the engine. Without an engine, your car would just sit there. It would be incapable of movement, a lifeless shell. The engine is what transforms it from an inert object into a dynamic machine. It's the difference between a parked car and one that can take you on a cross-country road trip. The engine is the beating heart that makes all the difference. Engines may seem complicated, but they're really just clever machines. At their core, they operate on basic principles of physics and chemistry. Fuel and air mix together and ignite, creating a controlled explosion that generates power. This power is then harnessed to move the car. While the details can be complex, the fundamental concept is straightforward. Understanding this can demystify the engine and make it more approachable. They take energy from fuel and turn it into motion. This process is known as internal combustion. When you pour fuel into your car, you're essentially feeding the engine. The fuel is the food that the engine consumes to produce energy. This energy is then converted into mechanical motion, which drives the car. It's a fascinating process that highlights the ingenuity of automotive engineering. This motion makes the car's wheels spin and propels it forward. The engine's power is transmitted through the drivetrain to the wheels, causing them to turn. This turning motion is what moves the car. It's a seamless transfer of energy from the engine to the wheels that results in forward motion. Every time you drive, you're witnessing this incredible process in action. Understanding how an engine works can make you a smarter car owner. It can help you diagnose problems, perform basic maintenance, and make informed decisions about repairs. Knowledge is power, and when it comes to your car, understanding the engine can save you time and money. It can also give you a greater appreciation for the technology that makes modern driving possible. You'll appreciate the magic happening under the hood every time you turn the key. The engine roars to life, ready to take you wherever you need to go. It's a moment of connection between you and your car, a reminder of the incredible engineering that powers your journey. So next time you start your car, take a moment to appreciate the heart of your vehicle, the engine that makes it all possible. Most cars use what's called an internal combustion engine. Internal combustion means the controlled explosions happen inside the engine itself. Think of it like a miniature, contained fireworks show that powers your car. These explosions provide the force to move the car, but instead of shooting off like fireworks, this force is harnessed to turn the car's wheels. It's a fascinating process that happens thousands of times every minute. The heart of the action happens inside the engine's cylinders. Imagine these cylinders as tall, narrow rooms. Inside each cylinder is a piston that moves up and down. These pistons are like the engine's muscles. They are pushed down by the force of the explosions, and this movement is what ultimately powers the car. The up and down motion of the pistons is crucial to the entire process. But how does the up and down movement of the pistons make the car move forward? That's where the crankshaft comes in. The crankshaft is a cleverly shaped shaft that connects to all the pistons. As the pistons move up and down, they push on the crankshaft. The crankshaft's shape converts this up and down motion into a rotating motion. It's like a merry-go-round being pushed by people jumping up and down. Section 5. The four-stroke cycle. A dance of air, fuel, and fire. The engine creates power through a repeating four-step process called the four-stroke cycle. These four strokes are intake, compression, combustion, and exhaust. Each stroke is vital to the engine's operation. Think of this cycle as a well-choreographed dance. Each step must happen in the right order and at the right time for the engine to function smoothly. Section 6. Intake. Breathing in the ingredients for power. The first stroke is called the intake stroke. This is where the magic begins, setting the stage for the entire combustion process. The intake stroke is crucial because it determines how much air and fuel mixture enters the cylinder, which directly impacts the engine's performance and efficiency. During this stroke, the piston moves down the cylinder like a syringe pulling back. This downward motion creates a vacuum, which is essential for drawing in the air and fuel mixture. The precision of this movement is vital, as any deviation can affect the engine's overall performance. As it does, it sucks in a mixture of air and fuel through a valve. This valve opens at just the right moment, allowing the perfect blend of air and fuel to enter the cylinder. The timing and coordination of this process are critical, as they ensure that the engine receives the optimal mixture for combustion. This air and fuel mixture is the engine's food. Just as our bodies need a balanced diet to function properly, the engine requires a precise mix of air and fuel to operate efficiently. The quality of this mixture can significantly impact the engine's power output and fuel economy. Just like we need food for energy, the engine needs this mixture to create power. The combustion of this mixture releases energy, which is then converted into mechanical work. This process is what propels the vehicle forward, making the intake stroke a fundamental part of the engine's operation. The intake stroke ensures the cylinder is properly filled for the next step. This step is crucial because it sets the stage for the compression stroke, where the air and fuel mixture is compressed to prepare for ignition. A well-executed intake stroke ensures that the engine runs smoothly and efficiently, providing the power needed for various driving conditions. The intake valve's operation is a marvel of engineering. It opens and closes with precise timing, allowing the right amount of air and fuel to enter the cylinder. This precision is achieved through a combination of mechanical and electronic controls, ensuring that the engine performs optimally under different conditions. Different engines have varying intake systems, each designed to maximize efficiency and performance. Some engines use naturally aspirated intake systems, while others employ turbochargers or superchargers to force more air into the cylinders. These systems enhance the engine's ability to produce power, making the intake stroke even more critical. Engineers continuously work to improve intake systems, experimenting with new technologies and materials to enhance performance. Innovations such as variable valve timing and direct fuel injection have revolutionized the way engines breathe, leading to more power, better fuel efficiency, and lower emissions. The future of engine intake systems looks promising, with advancements in technology paving the way for even more efficient and powerful engines. As we continue to push the boundaries of what's possible, the intake stroke will remain a fundamental aspect of engine design, ensuring that our vehicles perform at their best. Section 7. Compression, combustion, exhaust, from squeeze to boom to goodbye. In this section we will delve into the intricate processes that occur within an engine cylinder, transforming a simple mixture of air and fuel into the powerful force that drives your vehicle. Understanding these stages is crucial for anyone interested in the mechanics of engines or looking to maintain their vehicle's performance. Next comes the compression stroke. This is a critical phase in the engine's cycle. During this stroke, the piston moves upward in the cylinder, compressing the air and fuel mixture into a much smaller volume. This compression is essential because it increases the mixture's temperature and pressure, setting the stage for the next explosive phase. The piston moves back up, squeezing the air and fuel mixture tightly. This action is akin to squeezing a spring. The more you compress it, the more energy it stores. In the case of the engine, this stored energy is in the form of potential energy within the compressed air-fuel mixture. The tighter the squeeze, the more powerful the subsequent explosion will be. This compression makes the explosion more powerful. When the air-fuel mixture is compressed to a high degree, it becomes highly volatile. This volatility is what makes the next phase, the combustion stroke, so effective. The energy released during this explosion is what ultimately powers the vehicle, converting chemical energy into mechanical energy. With the mixture compressed, a spark plug ignites it. The spark plug is a small but mighty component that delivers a high-voltage spark to the compressed air-fuel mixture. This spark is the catalyst that triggers the explosion, igniting the mixture and causing a rapid expansion of gases. This is the combustion stroke. During this phase, the ignited air-fuel mixture rapidly expands, creating a high-pressure environment within the cylinder. This expansion forces the piston downward with tremendous force, converting the chemical energy of the fuel into mechanical energy that drives the crankshaft. The explosion pushes the piston back down with great force. This downward movement of the piston is what generates the power needed to turn the crankshaft, which in turn drives the wheels of the vehicle. The efficiency of this process is crucial for the overall performance and fuel economy of the engine. Finally, during the exhaust stroke, the piston moves up again, pushing the burnt gases out of the cylinder through an exhaust valve. This is the final phase of the engine cycle, where the spent gases are expelled from the cylinder, making room for a fresh charge of air and fuel. The exhaust valve opens to allow these gases to escape, ensuring that the cylinder is ready for the next intake stroke. This continuous cycle of intake, compression, combustion, and exhaust is what keeps your engine running smoothly. Section 8. Putting it all together, the symphony of motion. This entire cycle intake, compression, combustion, exhaust, happens continuously in each cylinder. The crankshaft gathers the force from all the pistons firing and turns it into rotational power. This rotational power is transferred through a series of gears and shafts to the car's wheels, making them turn. It's a remarkable symphony of motion, all orchestrated by the engine. Section 9. Conclusion. The engine that keeps us moving. The car engine is a marvel of engineering. It takes a simple concept, controlled explosions, and transforms it into the power that drives us forward. Understanding its basic operation gives us a greater appreciation for the complexity and ingenuity under the hood. The next time you start your car, take a moment to think about the amazing process happening within the engine, the heart of your vehicle.